welcome to the fourth video in this series where we will discuss my relational model and how I went about designing it. So in the previous video we explored how onion architecture and domain-driven design help keep our code modular and scalable. Today we'll dive into the relational model that underpins my SaaS platform. One of the biggest challenges in building a SaaS platform is keeping tenant data separate and secure. How do you ensure strict data separation while keeping performance high, scale and manageable? That's part what we'll explore today. I'll walk you through how I designed a relational database model that supports multi-tenancy and ensures data security, and some additional steps like low-level security that can further enhance tenant isolation. We'll cover those in detail later in this video. So first off, what is multi-tenancy? Multi-tenancy is a software architecture pattern in which a single instance of software runs on a server and serves multiple tenants. These systems are designed to be shared rather than dedicated or isolated. In a multi-tenant system, multiple organizations or tenants share the same software instance while keeping their data separate. Each tenant has its own users, permissions and data, but everything runs on a single deployed application and database. This is different from multi-instance architecture, where each tenant gets a separate software instance and database. That can lead to higher costs in maintenance overhead. So for my SaaS platform, I chose a single database multi-tenant approach, meaning all tenants share the same database but can only access their own data. This approach simplifies deployment and scaling while keeping costs lower than maintaining separate databases per tenant. So I'm just going to switch to SQL Server. I'll walk you through my schema design, how tenant isolation is enforced, and the security measures I've already implemented, as well as those that I plan to add. So let's dive into the DB model. This here is from the main API. This handles tenants, the locations, and the sites. All the tables have long as a I'll have long as the primary key. I'll begin SQL Server, and a external identifier key. So the primary key is the clustered index. So the reason for adding long as a type for the ID is the clustering indexes. It works well, it's rapid for querying. As mentioned, there's also an external identifier column, and this is just a GUID, and this has a unique non-clustered index assigned to it, and that's to speed up querying. There's two reasons for this. When querying within the database, I can use the ID column in my joins. The clustered index will provide fastest results. And then when I'm querying from outside of the database, I use external identifier, which is a GUID. And these are hard to guess, so I don't leak identifying key values outside of my database so that they appear in URLs, and that provides a little obfuscation of the underlying structure. I'm not entirely sure what the pattern is called, but I've seen it a few times in my career. Um, I also felt that when it came time to distribute the database across regions, if you remember, dream is to expand outside of the UK with this platform. It will be easier to do so using longs rather than GUIDs as primary keys. By setting ID ranges per region, I can make sharding and data distribution simpler. Also, a clustered index performs better than a non-clustered index, and since bigging grows sequentially, it minimizes fragmentation and improves performance. Using GUI for primary keys would require making them sequential to get similar performance, but that introduces security risks as predictable IDs can be exploited. I also use datetime offset instead of datetime because if I expand into Europe, sorting timestamps with their offset, storing timestamps with their offset makes it easy to handle regional time zones in the application. This ensures that if I ever need to adjust timestamps based on the tenant's location, the data will be structured correctly. Pardon me. All the tables except for tenant have a tenant identifier column. That one here. This allows me to tie the record back to a specific tenant, ensuring that we don't leak information across the various tenants that will use this application. I'm just going to now create a diagram so we can visualize this. So as you can see, it's a micro database containing 3 tables. Tenant has got a one-to-many relationship with locations. By this, I mean that a tenant can manage multiple locations. A location belongs to a tenant in a one-to-one relationship as it only exists once within a tenant. Similarly, a location can have many sites, but a site will only exist at one location. You might have noticed there's a fourth table, concierge sites. This is to be removed. It's unnecessary. The user is assigned a concierge role, and there is a joining table between the ASP.NET users table in the users API. So we can determine this by querying those relationships, and that negates the need for a dedicated table. And we'll remove that at a later date. I will quickly show the users API. This uses ASP.NET identity. These tables come out of the box. However, to support multi-tenancy, I needed to extend the base identity classes to include a tenant ID column. Entities. So you can see I've extended the class. The details I require. We've got some auditing fields. You might have noticed these are present already on other tables. Here we see. I also have the columns for the current tenant on site, location. I think some users may have access to multiple tenants at location. This helps keep track which one we're currently working with, making it easier to enforce permissions at database and application level. This was the database side of things. But in a future video, I'll walk through how I extended those ASP.NET Identity classes in C# to support multi-tenancy. I'll break down the code and show exactly how I handle things like tenant scoping and auditing. The residences database is more of the same. We've got a dwellings table. So we've got a dwelling table which contains information about the apartment, an dwellings table, information about the apartment, an occupants table that contains some basic information, and then a joining table between the two. When I build out the application for residents and provide a way for them to log in, this may likely change to a pattern, like how the concierges are implemented via the roles. Like this relationship. And I can get residents of the building a different set of permissions as well. For now, though, we don't have that functionality. Residents may move within the building. They could purchase a different flat that is bigger. Someone who is left in the property may purchase a property within the building. This just provides a way for them to move. I use soft delete. Yeah. Like this is deleted column. So in the joining table, I can flag the old record as deleted and add a new entry for the new entry. Add a new entry for the new residents that are now inhabit. The packages database, this is currently just one table. But you can see it has columns for the foreign key, such as the dwelling ID, concierge, that logged the package along with the audit columns. You'll notice that we store the GUID value and not the long, as this is outside the boundaries of the database. So this gave you some useful insights into design a multi-tenant relational model. If you're building something similar or have questions about multi-tenancy, drop a comment below. I'd love to hear your thoughts. And if you want to follow along as I build out the rest of this SaaS platform, make sure to subscribe so you don't miss the next video.